Good morning, everyone. Kalimera. We are here in Agrotica, and I'm going to tell you a little bit about fertigation and what are the solutions that ICL is bringing in this area. Before we go into detail, let's take a look to the European region and the crop areas under irrigation. We see that mostly it's South Europe where we have irrigation, and that we are actually in Agrotica in one of the main regions for irrigation in Europe, with more than 300,000 hectares. Other important areas are the Po Valley in Italy, as well as in Spain. When it comes to irrigation, we have mainly different irrigation systems adapted to the different farming systems, and they will allow different strategies for the fertilization management. So we have furrow irrigation, traditional system, water gun irrigation, which is quite frequent here in the area of Thessaloniki, a sprinkler or pivot irrigation, and last we have the localized irrigation. When it comes to the first three, it's by gravity most of the times, or sprinkler irrigation. We will use to apply big quantities of water, above 100 millimeters, and then the frequency of irrigation is a matter of days or even weeks. And in this case, the fertilization management will be done based on base fertilization in the soil plus additional top dressing. Here, ICL is bringing technology of control release fertilizers, coated fertilizers that allow control release based on temperature. But let's go to the other systems. When we have localized irrigation. Localized irrigation will be more frequent with less quantity, and it will allow us to go into fertigation strategies. So the benefits of fertigation is the possibility to adjust the supply of nutrients to the different phenological stages, as well as to adjust their quantities in terms of needs, specific needs that may appear eventually in the crop, or based on the yield target that we can adjust for more or less fertilizer supply. Oh, sorry. So normally, if we focus on NPK water-soluble fertilizers, we will be able to use different balances of NPK. This is the case of citrus. We will start with an N2-1 or N3-1 relation of NPK, plus a focus on magnesium for the growth of the new shoots, and then continue with a balance more in nitrogen, and later on more in potassium balance. So this is main advantage of fertigation. And also, by this way, by supplying together the nutrients and the water, we will improve the efficiency of the fertilizers. One requirement that we will have in fertigation is that we will need highly purified fertilizers, fully soluble, that are able to go through the little hole of the drippers. So this will require us of high quality fertilizers, plus additional filtering of the water with different kind of filters. Then we will need to prepare all those fertilizers on a fertilizer solution. And here we can go, we will be able to go with straights, with the basic soluble fertilizers, or we will be able to work with NPKs. Let's go first to the straight fertilizers. The straight fertilizers product range in ICL is Nova product range, and we have all the materials with a specific high or total solubility of the fertilizer, high quality and nutrient contents for organizing fertilization tank. The question we will have to keep in mind when we are using straight fertilizers is the compatibility between the different salts. We have one salt in ICL, which is a unique product, Peacid, with a 0,60-20 of P2O5 and K2O, so phosphorus and potassium fertilizer, with an acidifying power that makes it suitable to be mixed with any product. This unique product, is actually the basis of the NPK fertilizer of ICL that we will go afterwards. But if we are working on a straight, we can use this product in combination with any material except of magnesium phosphate. that is not compatible with any other product. What is Peacid? Peacid is a crystal. It's a fully soluble acidic. At a 1% solution, it leads to a 2.2 pH of the solution, so high acidic solution. It has very high solubility. Then it has minimal chloride and sodium concentration content. It's compatible with calcium and magnesium, and it can be safely used for drip irrigation or for the production of NPK fertilizers for drip irrigation, which is the case of actually FertiFlow product range, which is the NPK products containing Peacid and being possible to mix all kind of raw materials to get fully soluble NPK plus calcium, magnesium and microelements. The advantage of using NPKs will be to make it more simple, no probability, no possibilities to mistake in the mixing of different raw materials, and then the simplification in preparing the stock solution for the fertigation. FertiFlow includes a broad range of products for different kind of water. For hard waters, where we have to deal with bicarbonates and to get calcium and magnesium solubilized in the fertigation mix, to soft waters. And we will have the advantage of actually acidifying the water solution and the fertigation solution, that it brings a lot of benefits. First, it is the possibility, as said before, of putting together all the nutrients in the fertilization tank, in the stock solution. Second, to get this acidification of the irrigation solution for increased availability of nutrients for the crop. Then avoiding problems of clogging in the drippers, because this extra acidification and the control of bicarbonates in the water. Increased mobility of the nutrients in the plant and the uptake. Then we are also increasing efficiencies because of decreased losses of nitrogen due to volatilization because of this acidification, and improving also the water infiltration and water uptake in the end. For the preparation of the fertilization tank, I will better refer to a little demonstration. Actually, first, when we have the stock solution we are preparing, we will fill it up with water around 50 or 60% of the total volume. In this case, we are dissolving at 10% a potassium fertilizer, which contains also sulfates. So initially, it's hard to dissolve, but it contains all the material that it makes it more soluble, and the possibility to add or to create a 10% solution as a stock solution for the fertigation. I will play again. Then the pouring of the product, of the fertilizer, NPK or straight, it needs to be gently while the water is in agitation. And when it is dissolved, we will fill it up to the top, to the total volume of water that we are preparing our stock solution. So there is also, in this case, I would like to highlight one thing of NPKs and straight products. It's the need that they do not create any problem of foam. Actually, with other products, this is the case of our NK at a 10%, a similar product at 10% solution, it creates problems of foams in the tank of in the fertigation tank. Then, even in this case that we were dissolving one full bag into 150 liters, we managed to get fully solubility and no residues at all. That will create problem for the cleaning later on, or once it goes into the irrigation system of clogging drippers. Basic rule of thumb, it's to have the first quarter of the fertigation with clean water, then second and third quarters injecting the fertilizer, and the last quarter with only water. We need to make sure that all the drippers will receive clean water to avoid the accumulation of salts and then the reaction with the bicarbonates, with the CO2, atmospheric CO2, and the clogging of the drippers. So to make sure that every drippers, especially the ones at the end of the dripping line, get clean water, we need this one quarter with water. the nutrients will remain away from the surface to avoid also volatilization of nitrogen, and will remain in the root zone together with the water from the irrigation. But we know agriculture is as diverse as many farms we have in the world, because each farm has a soil type and it has a different source of water. There are some common values. For example, a water from well in a calcareous area like Thessaloniki or in Spain. Sorry, I didn't introduce myself, but now that I said, my name is Paco Morell. I'm agronomist for Europe in ICL, and I come from Valencia region, which is a citrus growing region. Now we are also exploring new crops like avocado, and we are actually dealing with similar conditions in terms of soil and water, like you are dealing here. So I'm referring to a water analysis from my region, actually. The one we irrigate actually in the farm that my family manages. In this case, we can find high level of bicarbonates. This will be causing some problems of compatibility. We are still in acceptable levels. We can find some waters with even higher levels. In some areas, this is a different water analysis from Murcia, southeast Spain. Here we may be dealing with sulfates, with high contents of sulfates. Also, for those who are students, let me mention one thing. You know about chemistry, you know cations and anions. The concentration is measured in milligrams per liter. But then we look in milliequivalents, which is related to the charge that it has. In any water that the nutrients or the minerals that are available in the water are solubilized, are dissolved, there will be a balance of the equivalents, because it's not the same having potassium or having magnesium. One is one charge, magnesium has two charges. So the milliequivalents takes into account the charges of the anions. So the water analysis, you can check that there is a balance. If you add the cations in milliequivalents, if you add the sum of the cations in milliequivalents and the sum of the anions, you will see that it's balanced. It means it's solubilized. Actually, when we create and when we check, we can do it in the field, like I will explain now, checking the compatibility of our water with our fertilization, with our stock solution for fertigation, or we can do it also on an Excel table by checking that our cations are balanced with our anions, and that we are supplying actually something that will remain dissolved in the water. So in the analysis of water, of course, it's the water that we are getting from a well, and if you check calcium, magnesium, and sodium, it's balanced with sulfate, chloride, in terms of milliequivalents. This was just for you. For you to think, chemistry is very important when we are dealing with agriculture. So do not run away, love chemistry, but let me come back to the topic. Sorry. So, okay, what kind of checkup we can do in the field? I mentioned if we are working with straits that we need to check the table of compatibilities. There is one product that is compatible with anything, Peacid. If we are working with an NPK, also we need to check that actually our model solution, that it's being possible because of the acidic power of certain components, will be stable when we mix it at 1% or we mix it at a certain rate with our irrigation water. So what can we do? We take a liter of our water for irrigation and 50 milliliters of our stock solution, one is dissolved. And we check for 1 or 2 hours if there is any precipitation. So this would be checking that actually the fertigation tank, the stock solution with high acidic because of the components, will be possible to remain dissolved once we inject in the irrigation of water. So this needs to be checked also. If we are initiating, because we may have sulfate contents up to 400 ppm, or our bicarbonates are too high, and we may need additional acidifying power But normally in each region you have the experience and you know what kind of water you are dealing with. So, and then we need to keep in mind our irrigation program, how much water we are going to be adding, and how we are going to split our fertilization, how many irrigation events we have, which will depend on our crop and on our soil. Do we irrigate every day on a sandy soil or in a mountain where we have 50% of stones, or we will irrigate every 2 or every 3 days with higher amounts of water? This is the crop water need for a citrus that I'm taking as a reference. Actually, we have the highest period of crop water needs is when there is increased evapotranspiration demand, which is summertime. But we have also high demand in springtime. What happens in springtime? That we may have rainfall and we don't need to irrigate. So if we are on a subhumid or in a semi-arid with frequent rainfall events, we may need to think to bring 30-40% of our fertilizer supply to the crop as a base fertilization on the soil surface in the areas of the drippers, to add on top of the soil certain part of our fertilization plan. If we have the rainfall, we will get the perfect water, which is the one from rainfall, with the nutrients, with the fertilizers we added on top of the soil. If we don't have the rainfall, those nutrients will solubilize with the water getting wet in the area of the dripper. So this is to think about. Then if we are in an arid or semi-arid, we will be bringing most of the water through irrigation. And here we can think to add 90 or up to 100% of our nutrients with fertigation. So our full fertilization program will be based in fertigation. So this depends on the rainfall and the probability of having spring rainfalls to define the best fertilization plan for your farm. So this slide, I took it from a presentation from someone from USDA in the US. Actually, we start the irrigation season. We can and we need to monitor that our irrigation is uniform. We can do this by checking the amount of water getting out in some points of our farm, or by checking how the crop is doing across. We may have a situation where we don't have uniform irrigation because of losses of charge in the dripping irrigation line, or that we are maybe having increased or too much water and too deep percolation. For this, nowadays we have a lot of tools of sensor in the soil that here in Agrotica you can check. There are many technologies available, easy to use, that will help us to understand how much we are irrigating and how deep our water is percolating in the soil. And then we have the perfect situation. The water is supplied in the rooting zone, so we manage to understand how much water we can bring into the soil, and we do the right frequency with the right amounts to supply the water and the nutrients in the rooting zone. Again, this can be followed by measuring the dripping lines, in the dripping line the amount of water we have, by visual examination of the wet areas across the dripping lines, or if we have the possibility, including sensors to monitor how much we are percolating in each irrigation event. My personal experience with sensor is that it helps to discover many more things about temperature, about electrical conductivity, and I highly advise the considering including at least 1 point for the checkup in the most difficult part of your farm, there to check this technology. Then what happens is that because of this precipitation, when the fertigation solution reacts with the atmosphere, we have the precipitation of the bicarbonates into carbonates, into calcium carbonates, and the creation of clogging in the drippers. This we can also visually see in the dripping lines by visual checking. And we will need to, every year before the irrigation season starts, to use an acidifying product that can remove all the bicarbonates. If we are also using organic matters and we are having clogging because of biofilms, we will need to use additional declogging products like peroxide hydrogen, or products containing this kind of products to declog the drippers from these biofilms that are being created in the drippers. Our solution from ICL is Peacid, safe to handle. We can create a high concentration 2 pH stock solution, and the injection rate will depend on how many drippers we have and which is the volume of water. Then we will be able to define a strategy for this cleaning of the dripper at the beginning of the season. For more details, consult with people from biosolids that are able to advise. But also keep in mind that during the irrigation events, our water-soluble fertilizers are including part of this Peacid, which is increasing the acidity of the fertigation, and that will allow during the fertigation season to avoid any clogging of bicarbonates. This is the advantage also of the uniqueness of our NPKs and FertiFlow product range. Well, thank you very much for your attention. Please, any question, comment? I'm very happy to go. Thank you.